Okay, 2.2, part 2. So we're picking up where we left off on slide 9. So we kind of touched on max and min values. Today we're going to go more into it. So we know if our graph is going up, if our parabola is going up, we have a minimum value. If our parabola is opening down, we have a maximum value. And our max or min is always our y value. So it is always going to be the y value from the vertex. So remember, your x value in your vertex is your axis of symmetry. The y value in your vertex is always going to be the max or min. For domain is any number that our graph touches for the x values. So for domain, we would go from left to right. For parabolas, our domains are always going to be all real numbers. So anytime we have a parabola, our domain is all real numbers. So our graph goes from negative infinity to infinity for the x values, so we would just say all real numbers. Now for our range, we start at the very bottom of our graph and go to the top. So for the first one here, our graph doesn't start until we reach this point. So our range is always going to be the y value where our graph starts. And then if it opens up, it goes to infinity. So this would be the y value to infinity. We would actually put a bracket at our y value, and then it goes to infinity. If it opens down, our graph is going forever in the negative direction, so our range would be negative infinity. And then it stops at whatever our maximum value is, so it would be just that y value for our max. So this is how we're going to write our range. And then when we open up, our graph starts decreasing and then goes to increasing. So we would say that it's decreasing to the left of our x value and increasing to the right of it. So you always just think, you read from left to right. So if you started here, you would be going downhill here, so you're decreasing. And you would be walking uphill here, so you'd be increasing. Again, even when we're opening down, we start from the left and then go to the right, so we start walking uphill, and then once we get to our axis of symmetry, then we change to walking downhill. So when it opens down, we're increasing to the left of our x value and decreasing to the right of it. Now we're going to look at some examples. Any questions here? All right, example 3. So we need to find the minimum value or maximum and describe the domain and range and where the function is increasing and decreasing. So the first thing we would need to do here is find our vertex. Even though it doesn't ask us for it, we need to find our vertex to find what our x value and our y value are. So what's that formula that we use to find our vertex when it's in standard form?
Negative b over 2a.
Perfect. Negative b over 2a. So we have our a, b, and c here. So we would just plug in our a and our b. So this would be negative 2 over 2 times 1/2. Negative 2 would just make it a positive 2, and 2 times 1/2 would be 1. So our x value in our vertex is 2. How do we find the y value in our vertex?
Plug in the x.
Perfect. We plug in 2 for the x. So we have 1/2 times 2 squared minus 2 times 2 minus 1. So 2 squared would be 4 over 2 minus 4 minus 1. So this would be 2 minus 4 minus 1. So this would be -3. Now, if we were to graph this, just a rough estimate of our graph, we can put our vertex, which is at 2, -3. Is our graph going to open up or open down?
Open up.
It opens up because our A is positive. So our graph opens up. So do we have a max here or a min?
Min.
We have a minimum value. So if we look here, we have numbers that go all the way up to infinity, but we can't specify what our maximum point here is. But what's important here is the minimum value, which is our vertex. So our vertex is what we're looking at for max or min. So it's always going to be a minimum when we open up. So just think when you are determining whether it's a max or min, you look at the vertex. Is the vertex at the lowest point of the graph or is it at the highest point of the graph? So here it's at the lowest, so this would be a minimum. What is our minimum value?
-3.
Perfect, -3. So our minimum always comes from the y value. All right, next we need to find the domain and range. What did we say about our domain when it's a parabola? Go back to the last slide. What did it say about the domain?
It's all real numbers.
All real numbers. The domain is always going to be all real numbers. Now our range, we start at the bottom and work our way to the top. So starting at the bottom down here, where does our graph start at?
3.
-3. Perfect. So our graph starts at -3, and then where does our graph end?
+4.
So remember, we're looking at the y values for range. So our y values are on the vertical, the y-axis. What is our highest y value here? Does our graph ever stop going up?
No.
No. So it would be infinity. All right, and the last thing we need to find is if it's increasing and decreasing. So on the left side of our graph here, are we increasing or decreasing? Remember, just like how you read from left to right, we start from the left and go to the right. So if I was a person standing right here, am I walking uphill or downhill going right? Downhill. So I would be decreasing. So I'm decreasing to the left of our vertex. So left of 2. And then the right side of our graph, we change from decreasing and then go increasing. So I'd be increasing right of 2. So for increasing and decreasing, we look at our x value. All right, we have one more example like this. We're gonna skip B, so let's do A. So where do we need to start here? What should we do to start?
You classify what's A, B, and C.
Perfect, so we have A, B, and C. And then we need to find our vertex, which is negative B over 2A. So we have negative 16 over 2 times 4. So what's our x value in our vertex here?
I have a question.
Yes.
How come you didn't?
Like this?
Yeah.
All we do is use the coefficient, so the number out front. So for A, B, and C are just the numbers out front. So we don't include the x's.
Oh, okay. Thank you.
So negative 16 over 8 would give us negative 2. So our x value in our vertex is negative 2. How do we find our y value? Plug in. So we have 4 times negative 2 squared plus 16 times negative 2 minus 3. 4 times negative 2 squared would be 8 minus 32 minus 3. No, this would be 16. So 16 minus 32 minus 3. 16 minus 32 is negative 16. And negative 16 minus 3 would be negative 19. So now we can graph this. So we go to the left 2 and then down 19. Does our graph open up or open down? It opens up because our A is positive. So it opens up. All right, so now do we have a max or a min here? A minimum. And what is our minimum value? Negative 19, awesome. We get the minimum from our y value. So it would be negative 19. Now what is our domain? What is our domain always for any parabola? All real numbers. And now our range, remember we look at our y values for our range. So what is our lowest y value here?
Negative 19.
Negative 19, so we put a bracket when we have the number. And then what is our highest y value here?
Infinity.
Infinity. Awesome. And then we put a parentheses when we put infinity. All right, next we have increasing and decreasing. So to start, are we increasing or decreasing? So if we were a person standing here, are we going uphill or downhill? So we're walking along our graph going from the left to right. So we're going this way. So we would be going down. So we are decreasing to the left of negative 2. And then we would be increasing to the right of negative 2.
I don't really get the increasing and decreasing.
What part do you not get about it? Like, okay, so we always start from left to right. We start with our smallest x value, so we start over here and then work our way to the right. So our graph starts here, and then we are going to the right, so we're going this way, so we are decreasing here. We would have a negative slope here, so that means that we are decreasing. We decrease until we reach this point, and then we change. So then after this point, we start to go up, so we're increasing. So you always go from left to right to decide if you're increasing or decreasing. And we always look at the x value, so that's why we pick -2. So we're decreasing until our x value hits -2, and then we start increasing everything to the right of -2.
Okay, thank you. Yeah.
All right, any other questions on this one? All right, so now we're moving on to graphing quadratic functions using X-intercepts. So now our equation, our function that it gives us is going to be in intercept form. So anytime we see a number times 2 parentheses, this is intercept form. So before we had standard form, vertex form, and now we have a third one, which is intercept form. So to find our axis of symmetry when we are given intercept form, we take our p, so it's going to be x minus some number times x minus another number. So we take that number and the other number, add them together, and divide by 2. So this is our formula down here to find our axis of symmetry in intercept form. Notice how we start with negatives and we use the positive, so we need to flip the sign of what it gives us. And then once we find our axis of symmetry, we just take that value for x, plug it into our equation, and then we could find our y value for our vertex. So let's look at some examples. So we set our formula for axis of symmetry is p plus q over 2. So we need to label the x-intercepts, vertex, and axis of symmetry. So our x-intercepts we get from these values. So this is where we cross the x-axis. So our x-intercepts, they're going to be coordinate points. So we need to change the sign of both of these. So we have -3, 0, and 1, 0. So we just change the sign of the value that's given to us in our parentheses, and then our y value is just 0. So if we were to graph this,
how'd you get the 1 and 0?
I got the 1 from here. So since it gave us a -1, we had to change it to a +1. And then the 0, for our x-intercepts, the y is always 0. So I'm going to go to the left 3, stay on 0, and then the right 1, and stay on 0. So the x-intercepts is where our graph crosses the x-axis. So our graph crosses the x-axis at these 2 points. Now this is our p and our q. To find the axis of symmetry, we add our p and q together and divide by 2, but we need to change the signs of our p and q. So this +3 becomes a -3, and the -1 becomes a +1. and we divide by 2. So this would be negative 2 over 2, which is negative 1. So our axis of symmetry goes right through negative 1. And now we can find our vertex. We know our x value is going to be the same as our axis of symmetry. So we start with negative 1. And then we take that negative 1 and plug it back into our equation to find our y value. So we have negative 2 times negative 1 plus 3. And then negative 1 minus 1. So this would be negative 2 times 2 times negative 2. So negative 2 times 2 would be negative 4. Negative 4 times negative 2 would be 8. So our y value in our vertex is 8. So we stay on negative 1 and go up 8. And here we have our vertex, which is 1 point, and then we have our 2 x-intercepts. So we have 3 points, and we can just graph it. So we just connect our points with our parabola. All right, let's look at number 6. So we need to graph the function, label the x-intercepts, vertex, and axis of symmetry. So first thing we can do is find our x-intercepts. What would our x-intercepts here be?
One and 5.
Remember, we need to change the sign.
Negative 1, negative 5.
Negative 1 and negative 5. Perfect. So for our graph, we are going to cross the x-axis at negative 1 and negative 5. Now to find our axis of symmetry, we just take the average of those two values. So we add them together, negative 1 plus negative 5, and divide by 2. Negative 1 plus a negative 5 would be negative 6. Negative 6 over 2 is negative 3. So our axis of symmetry goes right through negative 3. So what is our first value in our vertex? What is the first value in our vertex?
Negative 3.
Negative 3. It's the same as our axis of symmetry, always. And how do we find our second value? We plug in the negative 3. So we have negative 3 plus 1 times negative 3 plus 5. Negative 3 plus 1 is negative 2. Negative 3 plus 5 is positive 2. So this would equal 4. So our y value in our vertex is 4. So we go to our graph. We go up 4 and to the left 3. So our vertex is going to be right there. And now that we have 3 points on our graph, we just connect all 3 dots. All right, let's take a look at number 7. Last example today. What should we do first? Anybody? What do we do first?
Get the x points.
So our x-intercept. What would our x-intercepts be?
6 and 0. And then 2 and 0.
Perfect. 6, 0, and then 2, 0. So we're going to go graph those 2 points. So we go to the right 2, and then to the right 6. Now, how do we find our axis of symmetry?
The average of the two.
The average of the 2. So 6 plus 2 over 2. So it'd be 8 over 2, which is 4. So we go to the right 4, and we put our line right down 4. Now our vertex. What's our first value in our vertex?
4.
4. And how do we find our second value?
Plug it in.
Plug it in. So we have 1/4 times 4 minus 6 times 4 minus 2. So 1/4 times 2, negative 2, times 2. So this would be negative 4 over 4, which is negative 1. So our vertex, we're going to go to the right 4 and down 1. Now we connect all 3 dots with our parabola.